Hi, welcome to Waka Waka Breaking It Down. This is the Algebra 2 unit review on exponentials. So this is like your practice test. So this was definitely something you should be thorough in knowing everything backwards and forwards. So let's check it out, problem by problem.
Good luck on your assessment, math students.
If you hear a bunch of noises, I'm at the airport right now, so that's where this video is being made. Um, yeah, that's just a random person. I don't know who that was. Okay, so here we go. When you're working with exponentials like this, I usually try to focus on the power of a power first. Like you can see down on this one down here in the bottom right hand corner, that square. I'm going to work with those first and distribute those into any kind of negative or any kind of parentheses I have. And then we're going to work with negative exponents second and try to flip those around. So bottom to the numerator to denominator or denominator to numerator, vice versa. So here we go. Let's distribute these out. So this 4 is going to go to the -3, so it's going to look like this. And I'll kind of break down a couple of these, and then the rest I'll go a little faster. But this will be whoops, it's supposed to be to the 4th power, not the 2nd power. Scratch, 4th power. There we go. So -3 to the 4th power, -3 times -3 times -3 times -3. So that's 81. And on the test, this is going to be a no calculator part. You can see that up here. But you always have your baby calculator, so you can do some, basic multiplication stuff if you need to. Now, when you have a power of a power, they multiply. The exponents multiply. So this is 2 times 4, not 2 plus 4, but 2 times 4 to make 8. So that's your answer. Um, just make sure that a power of a power distributes into that whole parentheses. Don't get confused. Like when you look at this, don't think that this 3 power is going to the 33. That's not part of it. You really have to think about these as being separate entities. So the 33 and then the x to the third, they're separated by multiplication. We just don't write the symbol because it's like a number and a letter and it's not really confusing. So we don't need to write the symbol. But those are separate. This 33 is not raised to the 3rd power. So you don't have to worry about that. Don't have to put them together. So we got 33 divided by 11. That's just 3. I cancel 3 of these x's and I have 5 left over on the bottom. So you just have x to the 5th on the bottom like that, right? Now the answers to all these are down at the bottom. If you scroll all the way to the bottom, the answers are written down there. So if you want to look at all these as a little faster, and move on. So like I said, I won't do all these in detail. This one, there's no parentheses, so the -3 is only going to the x. This one on the bottom left, there are parentheses, and the reason we put both of these on here is so you could see the difference, right? This first one, the -3 is only on the x, but this one down here, the -3 is outside the parentheses, so you have to do both pieces, 2 to the -3rd and x to the -3rd, right? And then we're going to flip things around, negatives go to the bottom, and I'll have 2 to the 3rd power is 8, and x to the 3rd, and we'll be done. Right? Once you have positive exponents on everything and things are simplified, then you're done. Okay, now we're multiplying. So 4 times 7, 28. When you multiply the letters, and again, like I know there's lots of parentheses going on, and don't get too confused about what you multiply. Just put numbers with numbers and letters with letters. So n to the 5th and n to the -8. When you add the exponents, so when you multiply like this, you're going to add the exponents. You're going to get 5 minus 8, which is -3. And then, of course, I'll flip that to the bottom, make it positive, and get rid of that, right? And that's what you'll end up with. So a power of a power, like up here, you are multiplying exponents. But when you have two things multiplied, you're adding exponents. Okay, so a little different. Let's take a quick look at those answers. You can see here that first one was there that we did, right? And then we have this negative exponent on C. Let's take a look at that. That negative exponent is going to move to the bottom, but the 2 stays where it is, right? So you can see that. We did this one where everything went to the bottom because it's a negative exponent, right? So you see everything went to the bottom. Okay, and then we just did E as well. Let's take a look at F maybe, and then there's a few more we'll briefly hit on. So the 4 is outside the parentheses, it stays. The 3 is inside the parentheses, so it gets squared to 9. X cubed squared is x to the 6. You multiply them, right? Not add. And then y to negative 5 to the second. That's y to the negative 10. And the stuff on the bottom just stays on the bottom. Now we're going to try and simplify things, of course, and put x's together with x's and y's together with y's. And we want to simplify our numbers as well. Like I know 4 goes into 12 3 times. I know 3 goes into 9 3 times, right? And then this is an x to the negative 4. So I'll write it over here on the side. I got x to the negative 4. That's going to move to the top to make it positive. So I have x to the 6th and x to the 4th. That's x to the 10th on top. And then I have y to the negative 10 on top. That moves to the bottom and makes y to the 30th on the bottom. So we're moving negative exponents up and down and changing them to positive. So you can see that answer right here over at F.
Yeah, so think of it like,
okay. Let me clear that out. Okay, moving along a little faster now. One thing I should just point out on this problem on G is that we have something to the 0 power. That's just going to go to 1. So I basically don't even have to write it. It basically just disappears because 1 times anything just leaves what it is. So that part is just gone. And then you can do what we did before on all the other ones. All right. The other thing I should point out or just mention real quick is that a negative number does not mean a negative exponent, and vice versa. If you have a negative exponent, that doesn't mean that it's a negative number. Those are different things. They have different meanings. So please keep those straight. Like in this case, I'd go negative 2 cubed, which would be negative 2 times negative 2 times negative 2, which is your negative 8. And then y to the 15th. 4 squared, 16. Then y to the negative 4. But when I did this y to the negative 2 to the second power, this negative is an exponent negative. It doesn't make the 16 negative or anything like that. Right. So we can put that together. We're not done yet, right? Negative 8 times 16, and then this will become y to the 11th, right? So you can see all that. Like I said, answers are posted at the bottom. They look like this down at the bottom. So you'll see that's the answer to G there. If you have trouble with any of these, just go find your teacher or the resource room, and you can kind of work your way through them. Okay, the next pieces, you can see all these down below here have fractional exponents. When you have a fractional exponents, they are roots. So this is a square root. That's a square root, square root, square root. These are all square roots. If there was a 3 on the bottom, then that would be a cube root. So sometimes, like in this case, it's just square root of 100, which is 10, right? But if that was a 3, let's imagine this was a 3. If that was, then I'd have the cube root of 100, which in this case doesn't come out very nice, but a lot of times you get numbers that you could do, like the cube root of 27, for example, would be 3, right? So that's a possibility, something like that. We give you something that you could do a cube root of or a 4th root of if we wanted, right? Even a 5th root, whatever we wanted to give you. Again, negative exponents flip things over. And then the number on the top is a power just like it always has been. So you can see how H and J are very similar. They both have a square root to them, but J has the 3 on top. So this one ends up being 10, the square root of 100. But down here, after you do the square root, you still have to cube it. So you end up with 1,000, right? 10 cubed is 1,000. So just an extra step. This is, again, almost the same thing, but now we added one more thing. We added the negative. So I had 1,000, but because it was a negative exponent, it becomes 1 over 1,000. So it gets flipped, right? So you just got to work those pieces one by one. So you can see those here, right? We went from 10 to 1,000, and then 1 over 1,000. All right, let's move on from exponents. I didn't do every single problem, but hopefully I gave you the main points of negative exponents and roots because they're fractions, or when do you multiply, when do you add the exponents. Those are things you got to watch out for. All right, so explaining how this works. So the reason that we multiply exponents of exponents is because of this idea. So if these parentheses here, whatever's in the parentheses is cubed, that means we're going to take everything that's in there times itself 3 times. So if you expand it out, it kind of looks like this, right? And on the test, we actually want you to do something like this and show us what's going on there. So this is how you show your work and get your full credit. So x squared, x squared, x squared, that's where your x to the 6 comes from. And then we got y times y times y, which is y cubed. And again, sorry if you hear other people talking. I'm in the airport. Okay, number 3, describing transformations. Let me just I'll kind of jump back and forth here. I always try to look at this number first usually, because that's like one of my reflections would be, and also the stretch. So in this case, on this -8, you're going to have a vertical stretch of 8. You just say it that way, a vertical stretch of 8. And then I'm also going to have that negative, which is going to reflect things over the x-axis. It's changing positive y values into negative and negative y values into positive y values. So it's reflecting over the x-axis. Things are flipping this way, right? Okay, that's what this negative does right here. All right, and then after you do your vertical stretch and after you do any kind of reflecting, for example, if I had a negative up where the x was, it would reflect over the y-axis. But you do stretching and reflecting first, and then we're going to shift. So this +7 over on A is going to move things to the left 7. It's always opposite of what you think, right? And then the number on the outside is going to shift it up and down. So this is moving it down 6. This is moving it up 4. And you just want to describe that. So real quick on this one, I don't have any reflecting. I don't have any stretching, but I am going to shift to the left 7 and down 6. On this one over here, I'm going to have a vertical stretch of 8. It's going to reflect over the x-axis, and it's going to shift up 4. So you got to put all that together. Let me show you the answer key to that part real quick, right? So you see, you just write it out in words like a sentence, and that's exactly what I wrote there. Okay, number 4, graphing them out. So let's do it. I like to start with a parent function, just kind of plot out like 3 points maybe. So if we have 3 to the x, I can tell that 3 to the x is kind of my base parent function. Whoops, so that's what I'm going to start with. And just plot a few points. Well, what if x was 0? Well, 3 to the 0 power is 1. What if x is 1? Well, 3 to the first power is 3. What if x was 2? Well, 3 squared is 9. So usually I plot those 3 points out first, and then I'm going to do all my reflecting and stretching and shifting with those 3 points. And I don't have to worry about the whole graph all at once. One thing to keep in mind is that your asymptote, your horizontal asymptote, is at +1 when you get done. Right now, for the parent function, it's just a 0. It's right here, right? So this will come down and it'll approach that asymptote at 0, but it'll never cross it, right? So I'm just keeping that in mind so I can think about the shape. All right, reflect and stretch first. So I have this negative in front that reflects everything over the x-axis. So this 0, 1 comes down to here. This point goes down to here. And this point goes all the way down here. And I'm just using x's to show their kind of intermediate step. All right, now we're going to shift all those points to the right 4 and up 1. So let's take these x's and go to the right 4. 1, 2, 3, 4, up 1. And this is going to be my final point. Okay, let's take this point. 1, 2, 3, 4, up 1. This point. 1, 2, 3, 4, up 1. There we go. So I have these 3 points like this, and I'm trying to ask myself, well, where does that go? Well, the asymptote has shifted up to +1 now from 0. So my asymptote is here, and you should probably show that on your graph on your test, or at the very least, on the side, you have to say y equals 1. That is your horizontal asymptote. All right, so let me draw that again, keeping the asymptote in mind, and it's going to go like that. All right, so as long as you kind of have those points and the asymptote, you're going to be good. All right, so that's it. That's what you need to do on your test. Like I said, start with a parent function, get a few points, stretch and reflect first, and then do your shifting. Let's do the next one. Sorry, I got to erase everything here first. Let me just talk you through this one. It has a base of 2, so I know 2 to the 0 is 1, 2 to the first is 2, 2 to the second is 4. So I got a basic graph like this to start. We're going to stretch it by 3, so that means all my y values get multiplied by 3. So instead of a 1, becomes a 3. Instead of a 2, becomes a 6. And instead of a 4, becomes a 12. So it's like way up here. Okay, then I'm going to shift it. So I did all my reflecting. There's no reflecting. I did my stretch, and now I'm going to shift it. So we're going to shift everything down 6. So that point goes down 1, 2, 3, 4, 5, 6. And this is my final point. And then this point goes down 1, 2, 3, 4, 5, 6. And then this one that used to be at 12, that's going to come down to here. All right, where's my asymptote at? Well, it's at -6, so it's way down here. And I know that because of this y-intercept, or it's not the y-intercept, because of that shift. All right, so that's going to come down through these 3 points and then approach my asymptote, right? So that's what it should look like in the end. All right, let's take a look at the answer here. Right, you can see how we ended up in those positions. To check your work, you can always take these points that you plotted in the end, just take them, put them into your equation and see if they work. They should actually match up to your equation, right? Like I could just take this 0.5, put it in my equation and make sure it comes out to -2. So when you're graphing, you can always kind of plug and chug and make sure your answers work correct. And again, those are at the bottom of this page, so scroll down to the bottom if you want to take a good look. All right, number 5. Now we're population growth and decay. So we have 334 million people in the U.S., and we want their population. So population P, we started with 334 million. I can just write 334 and then just remember that this is in millions. We're going to grow at 0.6% per year. So this is 1 plus 0.06 per year. Oh, but I didn't read far enough. If I keep reading, it says continuous growth model. So I don't want to use the 1 plus. I want to use the E version, right? The PERT. So I'm going to use E. My rate is 0.6%. I have to change that into a decimal. So 0.06, or sorry, 006, right? We got to move the decimal 2 places. And then I also have times T. But they said they want an equation for the year 2030 when we're starting at 2022. So that's going to be 8 years, right? An 8-year difference. So instead of T, I'm going to write in 8 years there. And then that's what you get, right? Solve your equation. This is just a calculator problem. So just plug it in your calculator. You can see up here it says calculator is allowed on this. All right, let me pop up the answer to this one so we can take a look, so we don't have to write it all out and watch me write it slowly. Okay, so you just throw this equation we came up with in your calculator. You should get 350.4 million. You'll see the next question says, write an equation to determine the population when the population will reach 400 million, right? So we use the same equation we started with up here, but now we're solving for some new time. So we have that x value there, right? But it has to equal 400. Well, how do we do that? Well, you're supposed to graph it, right? In the next unit, we're going to learn how to do logarithms, but we don't know that yet. So just graph this piece on your calculator. Graph this piece. So you're going to have like some kind of growth like this starting at 334 million and going up. And then you're going to have 400 and you're going to graph that. It's going to be a straight line. So you're just looking for that intersection using the analyze and intersection tool, which we've done many times in class, right? So just look for the intersection. When you do that, you should get 30 years. We started in 2022, so that takes us to 2052 when you get your 30 years. Okay, that's part A. Part B, now we're talking about Indonesia. We have 278 million to start with. We're growing 1% with a continuous growth, so same idea, where we use the PERT equation with the E in it, because it's continuous growth, right? So when you do that, it says write an equation to determine the population of Indonesia will equal the USA. Well, we already had the USA equation up here, so we're just using that again. But now we're adding in the Indonesia equation, right? 278 to start, our rate of 0.01. Just make sure you don't go 1.01. A lot of people make that mistake. You don't want that one is already part of E. It's part of the calculation or the proof of E, right? So it doesn't need to be written there. It's just the rate that's been turned into a decimal. Okay, and you can see that X is in both of these equations. All right, so what's that going to look like on a graph? Well, the 334 is going to go like this, and it's going to grow. But remember, it starts at 334 and grows at a kind of a small rate, like 0.6% is pretty small. Versus the Indonesia one's going to start lower down at 278, but it's going to grow faster. So they're going to have similar shapes, but one's going to increase a little faster than the other, and you should eventually have that intersection. So just graph both of those out on your calculator. Make sure you're very good at changing the window on your calculator, being able to go into your menu and then go into window and the window settings, and being able to deal with that, right? So on your calculator, you need to be able to go into window like here and see your window settings, right? And being able to change your domain of your X and your domain of your Y in order to get a good window. Yeah, you need to be good at that. And it just comes from looking at your numbers. Like I know my Y value needs to be up around, more than 200 million, and then probably less than 500 or 600 million, probably. I don't know where the intersection actually came out. But then the X value, the domain for the X, is going to be in years. So you can see the answer was at 46 years. So hopefully I figure out that the window is like 20 to 50 or 20 to 60 or something like that. Just something that surrounds the 46 if I can find it. In the beginning, I don't know. So a lot of times I just go 0 to 50 and then go from there, right? You just adjust it and adjust it and adjust it until you get it. Okay, let's move on. Number 6, maximum storage for iPhones can be modeled. So they're giving you an equation. We can see this is exponential growth. I have a 26% rate. I'm assuming it's a yearly rate, which it is. So that's a yearly rate. I'm starting with 16, what are we starting with? Gigabytes. So in the beginning, we had 16 gigabytes, and then we're increasing by 26% per year. All right, so what's the real world meaning of all these numbers? So 16 is the initial amount in gigabytes, 16 gigabytes. 1.26, that's the rate, so we're increasing at 126%. If I put 3 into my equation, like we actually want you to put 3 in, so you got to put 3 into your equation and solve. So we put 3 in. Oh, you really should solve for that and get a number, but so it would be 3 years since 2007. So in 2010, what the storage capacity is, that's what this represents, right? This one is a negative X, so that means a negative time. So that means 2 years ago, so like in 2005, that would be the storage capacity back then. So here's the answers. You can read through there, just pause it, or look at the bottom of your paper. Okay, and then we're going to solve for part B here. It says look for 2016. From 2007, that's like another 9 years. So in your equation, you'll see that we are putting 9 into the time period. And again, this is just a calculator problem. Throw it in, you'll get 128 gigabytes. Okay, we're investing at different amounts. So we're trying to compare these, right, and say which one's better. Well, I know that when you compound continuously, you're going to get the most money, right? It's gonna give you more interest on top of interest. So that's what you want. I know this is going to be the answer. Now, this is a test. You have to show your work. So we need to see this equation and we need to see that answer. We need to see this equation, we need to see that answer, and we need to see this one. So you have to do all three. All right, so this one is 8.1% and it's compounded just once a year. This one's less percentage, but it's compounded more, compounded quarterly, right? And then this one is 7.8% and then compounded continuously. And that's maybe the extra piece that we didn't notice right away. The percentage is going down, even though the compounding is going up. So that's kind of a mystery about which one's actually going to be better. If these were the exact same rate, then I know the compounding continuously would be the highest one. But they're not the same rate. This is actually the lowest rate. So maybe it kind of offsets it a little bit, right? So let's take a look. What do we got? Whoops, got ahead of myself. All right, number 7 here. So they try part A, right? This is just once a year for 6 years. There's no extra compounding. We're keeping the 0.081 as our rate, and you get your 319,000 yen. Okay, the next one says compound quarterly, so that's why you see the rate that we had. Now, we should put the 1 on there. That really should be there. So 0.081 divided by 4. And then instead of just 6 years, it's 24 months, right? You have to take your 6 years times 4, well, not months, I'm sorry, quarters. So 6 years times 4 quarters each, that's 24 quarters, right? So that's the reason the equation is written the way it is. You don't divide the whole thing by 4, just the rate part, right? The 1 stays out by itself. That's the 100% that you started with each time. All right, so that comes out to 321. It's a little bit more than the last one. And then let's look at the last. So the last was compounding continuously, same starting amount. We put the rate in there. This was a different rate, wasn't it? So the 1 doesn't go there. Sorry, I made a mistake when I said that. That 1 is not there because it's a different rate. This is 7.8%, so the rates change there, you see. Again, we don't put the 1 with that either. There's no 1 there. And then we multiply by 6 years in the power, of course, right, using E. On the calculator, make sure you are using the E button on the left. Over here on the left, you see it? Right, over there on the left. You don't want to use the E button down here. This E button is only a letter. It is not the E you're looking for. So don't use that. Okay. Oh, sorry, I didn't answer the question, did I? Whoops, wrong one. Let's try this one. So it looks like the middle one was actually a better deal, even though the last one had continuous compounding, which is usually the best one, but the rate went down so much that it offset it by a lot, enough to make the second one actually the better deal. Okay, back to the questions. Moving on. Okay. So we got the rate of growth during that month. Let me just pop up the answer to that one. Not that one. This one. Okay, so let me put that down here. And so we got 503 new cases. And then we ended up with 80,000. And we're trying to solve for the rate after, like, it went from 2022. Oh, that's for the last part? No. I was trying to figure out where they get the 31 from. I think this is supposed to be a different year right here. This is supposed to be 31 years later, so it's supposed to be like 50. That can't be right. Oh, this is in. Sorry, brain's not working there. This is months, right? Months. So we're talking about different months. Something's not right with this time. This should be like 2022 or something like that, because they did 31 months, so that should be like, almost 3 years, right? So one of these is wrong. I think this one should be the 2020. I think is that's supposed to be going on there. So maybe there's a typo mistake there. Anyway, let's just go with it. So we started with 503. We ended up with 80,000, and that was 31 months later. So we're looking for the monthly rate. Remember, the rate and the time period always have to match. So it's 31 months. We solve for the rate. Now this one, you don't need your graph. You do not have to graph this one because you're not looking for the exponent. The only time you have to graph is when you're looking for the exponent. All right, we can directly solve this. Just grab your calculator and you show some work. So we're going to divide by the 503 first, okay, and get this number. Then you're going to get rid of that power by doing the root of that. So, if this was a 2, we'd do the square root to solve. If it was a 3, we'd do a cube root to solve. Now it's a 31, so we're going to do the 31st root. Another way to do that, you can do the 31st root. There's a button on the calculator for that right over here on the left. You'll see right here. I don't know if you can see that right in there. There's a little root button. But you can also do a power. You can do a fractional power to do the same thing. So you can just make that raised to the 1 over 31st power, and that'll do the same thing. Check it out. Both of them work. You should get 1.1777. Okay, we subtract our 1, and you'll find out the rate. We have to move the decimals to change it to a percentage, but there you go. 17.8%, but that's a monthly rate. That's really high for a monthly rate. Like every month it's growing by 17%. That's really high. All right. So this is just an example of solving without having to graph it, right? Number 9, we're getting there. Just a couple left to go. We got endangered species, the orangutans, and it's declining at 8% per year. So this is an example of declining. Most of the ones we did so far were growth. So again, let me just pull up the answer, show you. We can talk about it. So you'll see in the equation and the answer here, you have your starting amount, 230,000. And because it's declining, it's 1 minus 0.08 now, not 1 plus, right? And it's just compounding once per year, so you don't have to do anything else to it. And then on our power, we're going from 2010 to 2021, so that's 11 years. All right. A lot of people take the 1 minus 0.08 and change it into 0.92. That's totally fine. You can start with that, no problem. And then this is just a calculator problem. Throw it in, and you should get your 91,900. Let's look at part B real quick. Now they're asking for the half-life. All right. So if I started with 230,000, that means I have half of that left over if I'm looking for half-life. So half of that is your 115,000. Again, you can just solve, but all of a sudden we have a time period, right? We're looking for how long does it take to end up with half of what you started with. So this is another graph problem, right? So back to graphing. I'm going to get something that declines this time, and then I'll have my 115,000 that's flat, and I'm going to be looking for that intersection of those two. Check it out. Play with your window. Make sure you have a window that's going to show these numbers, right? And the x is going to go from like 0 to 10 or something, and then you should be able to find that 8.3 years. All right, last problem. All right, this is one of those problems where it's like doing a good deed, or you tell a joke, or it's like the rumor mill tree or something, right? So we have 5 people, and they're going to hear the funny joke, and then every hour they're going to go tell 2 of their friends the joke, right? And then we want to see how many people have heard the joke after a few hours or whatever, right? Okay, so we tell 2, 2, 2, but we're starting with 5. So you'll see at time 0, at hour 0, 5 people knew the joke. And then we're going to double that each time, because they're going to tell 2 people. So that means 10 people know. And they're going to tell 2 people. So that means 20 people know, right? And then we're going to go another 2. That's 40, right? So it's like how many new people are hearing this joke every time, right? So 5 people, then 10, then 20, right? It's just double, double, double. So we can fill that in. Let me show you the answers here at the bottom real quick. Well, maybe real quick. Sorry. Computer's being a little jumpy. Hold on a sec. There we go. So there's our table, like I showed you. And then you just graph those out, right? 0 is 5, 1 is 10, then it goes 20, 40, right? We go 80 or whatever. So it's just a quick plot. This is something you're going to have to do on your test. Just plot something like that out on your own. Right? If I wanted to write the equation to match that, again, I'm starting with 5. The rate is double, 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 so it's just 2. And then we have the time period as the power, right? Part D is asking, well, what about after 9 hours? So, okay, let's just put 9 into our equation. 2 times 2 times 2, 9 times, right? And then times 5. So just throw it in your calculator, but make sure you put context on it. You have to have the context. So this is how many new people heard the joke after 9 hours. So if it was midnight, then that means 9 a.m. Okay, and then the last one, we want to find out how many hours it takes before it's gonna, we're gonna be telling a million people at once, which obviously is not reasonable unless it's online, I guess, but it's possible. Again, this is that situation when you have an exponent is the unknown. That's what you're solving for. When you see that situation, that's when you have to graph. All the other cases you should be able to directly solve, but this is graphing. So again, graph the left-hand piece, and we already know what that's going to kind of look like here, right? And then graph the right-hand piece, but now this is a million, so this is going to go way up, and then you're going to have a million, and then you're going to look for that intersection again. Again, your window has to match these numbers, otherwise you're not even going to see it on your screen. So change your window, make sure it goes up past a million so you can see it, and then it looks like it's going to take about 17.6 hours. So when you pick your window, pick a window that makes sense. Like, okay, let's just go, I don't know, 20, 30 hours and see what happens. And then I have to make sure this is at least a million. So I want to go more than a million so I can see what's going on. All right. This is exactly what you're going to have to do on your test. You're going to have to write this domain and show us that you have an idea where the window is. All right, and then that's it. That's the whole practice test. The real test will be very, very, very similar. Get used to the idea that some of the tests you're going to have a calculator, some of it you will not. Your teacher will give you both pieces of the test at once. Then you're going to have to turn in the no calculator section first before you grab your TI Inspire. Although you can use the little baby calculators on the whole test. All right, good luck studying. Please go to the resource room or ask your any teacher in the math department or your substitute teacher, anybody, for help, right? Ask away. I'm sure your friends can help you too. Good luck.